factor. So three configurations are available. One is quarter wave coaxial cavity, half wave coaxial cavity, and a coaxial cavity with a shortening capacitance. So the what you see here, A is going to be a quarter wave cavity, or I can say it corresponds to lambda by 4. And what you see here, it is going to be half wave lambda by 2. And third one is coaxial cavity of a particular length, and you have a capacitor, shorting capacitor C. So three configurations are available. And for a quarter cavity, you know the length will be 2 and odd multiples of lambda by 4. And for half wave, it is going to be odd multiples of lambda by 2. And for resonant capacitor cavity, you are going to equate that to the reactance of capacitor. So it is going to be dependent on the value of capacitance. So L will depend on the value of capacitance. And the n value can be anything 0 to z naught, and the 0 n value start from 1 to 3, and z naught, you know, the characteristic impedance, it may be 50 ohm to 75 ohm depending on what network you are going to use. And C is the capacitance what you are going to use between the conductor and the starting termination. So you have different modes getting excited: TE mode, TM mode, TEM mode. So all these are different modes which are excited when you going to operate your cavity. And we have found out mathematically that when the value of B by A is 3.6, the power loss is going to be a maximum. Okay, so due to microwave radiation from the open end of quarter wave coaxial cavity, half wave coaxial resonators are more preferred because there is some radiation issues with the quarter wave section. So I'm going to prefer half wave section than the microwave resonant cavities. And the final Q value is given in terms of A and B. So Q is going to be the quality factor value is given. Derivation is not there for us. We just need to understand what is a resonator, how it works, what are the mathematics behind the resonator. That's all. L is going to be the length and D is going to be the gap. And you can see everything depends, all the parameters are coming here. And this is going to be the resistance of your resonating cavity. And this is the characteristic impedance Z0 of your resonating cavity. And lambda G is going to be the guide wavelength of your resonating